So hello everybody. Today we're going to be doing a nice problem. So we're supposed to express the circumference and the surface area of a regular regular polygon which has n sides and which is inscribed in a circle with radius r as a function of the number of its sides and r. Okay, so here on this picture we've got a heptagon, and it's a regular heptagon, meaning it has 7 equal sides and it's inscribed in a circle with a radius r. So how do we go about solving this problem? Well, the first thing that I want to do is find the approximate center of our circle. I think that's about it. And now I'm going to go ahead and connect the vertices of the heptagon with the center of our circle. So I'm going to be using this ruler. Okay, and like so, and another one, and just 2 more. Maybe I'm not drawing this as accurately as I'd like, but it doesn't really matter, you'll still get the point. Okay, now that we've connected this, we can see that we got 7 triangles which are exactly the same. Let's also notice that each of these sides has a length which is exactly equal to the radius r of our given circle. Okay, so let's just go ahead and focus on one of these circles, on one of these triangles for now. And this triangle is an isosceles triangle, meaning 2 of its sides are exactly the same length and one of its sides is of a different length. So we'll call this side of our triangle A, and we'll go ahead and remark that we can express A as a function of r. Okay, so how do we go about doing this? I'm going to go ahead and take yellow right here. So we know that this yellow line is the height of our given triangle. But what I also want to point out is this circle right here. As every circle, it has 2 pi radians or 360 degrees. And since we have 7 equal cutouts in it, that must mean that all of these angles must be equal to 2 pi over 7 in this case. But in general, it's going to be equal to 2 pi over n. And you can disassemble each and every regular rectangle in the same manner. So in order to express r, generally, we're going to be using the cosine theorem. So the cosine of 2 pi over n must be equal to this side squared plus this side squared minus this side squared. So that's going to be r squared plus r squared minus a squared, and everything over 2 times this side, which is going to be 2 times r times r. Of course, we can just rewrite this as the cosine of 2 pi over n is equal to 2r squared minus a squared over 2r squared. From here, it follows that a squared must be equal to 2r squared minus 2r squared times the cosine of 2 pi over n. And once we take out the square root of both sides, we get that a squared is equal, whoops, it's not squared anymore, that a is equal to r times the square root of 2 minus 2 times cosine of 2 pi over n. So we know what a is in terms of r and n. And since we know that a regular polygon has n number, has n same sides, we can just go ahead and multiply everything by n, and we'll get that NA is equal to NR times 2 minus 2 times cosine of 2 pi over n. And what's n times a? Well, think about it. In this case, we've got 7 times a, so that's a plus a plus a plus a plus a, etc., up to 7. So n times a is generally the circumference. I'm going to denote it by O. So we've expressed the circumference of a regular polygon inscribed inside a circle with a radius r in terms of the number of its sides and of the radius. So that's one part of our problem solved. Now let's go ahead and do something similar for the area. Notice that the area of any given triangle must be equal to any side of it times its adjacent height over 2. And since I've already drawn this yellow line, we see that this yellow line is its height. And the height from this red triangle, which is a right triangle, can be expressed by using the Pythagorean theorem. So by using the Pythagorean theorem, we get that height squared must be equal to r squared minus a over 2 squared, or height squared is equal to r squared minus a squared over 4, which can be rewritten as height squared is equal to 4r squared minus a squared over 4. Once we take out the square roots of both sides, we'll get that the height must be equal to 1 over 2 times the square root of 4r squared minus a squared. Okay, and we know that the side of the triangle that's adjacent to this height is a, so once we multiply both sides by a, we get that a times h is equal to a over 2 times the square root of 4r squared minus a squared. And when we divide both sides by 2, we'll get that ah over 2 is equal to a over 4 times the square root of 4r squared minus a squared. And a times its adjacent height over 2 is exactly the surface area of one of our triangles. So I'm going to go ahead and call it A1. Okay? So and we know what A is in terms of R and N. It's right here. So we're just going to plug it in to our final to this equation for A1. So A1 is from here equal to A, which is just R times the square root of 2 minus 2 times the cosine of 2 pi over n. And of course, everything's divided by 4. And times 4r squared minus 2r squared minus 2r squared minus 2r squared times the cosine of 2 pi over n. Once we simplify this a little bit, we'll get that A1 is equal to R over 4 times the square root of 2 minus 2 times the cosine of 2 pi over n, and times the square root of 2r squared plus 2r squared, but times the cosine of 2 pi over n. Once we once we take the partial root of this, we can pull out this r squared, and when we take out the square root, it will simply be r. But then let's put this r right here, so we'll get r squared over 4, and we can combine these two square roots in the following manner. So 2 minus the square root of 2 minus the cosine of 2 pi over n times 2 plus 2 times the cosine of 2 pi over n. And notice that here we've got a difference of 2 squares. So this is equal to r squared over 4 times 4 minus 4 times cosine squared of 2 pi over n. And then we can take out the 4 from the square root, and that will leave us with r squared over 2 times the square root of, we're missing a square right here, 1 minus the square root, and the square root of 1 minus cosine squared of 2 pi over n. And once we remember the basic trigonometric identity, we know that this quantity right here is just equal to sine of 2 pi over n. Okay, so all of this is equal to r squared over 2 times the sine of 2 pi over n. And remember, this is a1. Once we multiply everything by a, since we know that once we multiply everything by n, since we know that we've got n equal triangles, we'll get that the area of the entire polygon must be equal to nr squared over 2 times the sine of 2 pi over n. And this is the second part of our final answer to the given problem. I hope you enjoyed the video. If so, leave a thumbs up, subscribe, and I'll see you in the next one.